guys, welcome back to my YouTube channel again. It's me, Mabel. For today's video, we will having some tutorial about introduction of differential equation. I hope for this video I can help you to further understand what is differential equation or the DE. Okay guys, so let's move forward for this one. First is we'll learn about the learning objectives for this lesson for the differential equation. First is identify the order of the differential equation. Second is explain what is meant by a solution to a differential equation. Third is distinguish between the general solution and a particular solution of differential equation. Fourth is identify an initial value problem. Fifth is identify whether a given function is a solution to a differential equation or initial value of the problem. When we hear differential equation, what words came into your mind? What is differential equation? For today's video, we'll learn also the meaning or definition of differential equation. This is differential equation is an equation which contains one or more terms and the derivatives of one variable. For example, the dependent variable with respect to the another variable. Second is the independent variable. dy over dx equals f of x. And this is the second definition to further understand what is the DE or differential equation. It's an equation involving an unknown function of y equals f of x, y equals f of x, and one or more of its derivatives. A solution to differential equation is a function of y equals f of x, y equals f of x that satisfies the differential equation when the following and its derivatives are substituted into an equation. And also for this video, we'll learn the types of differential equation. Differential equation can be divided into several types, namely, first is the ordinary differential equation or ODE. The second is partial differential equation. Again, for this video, we'll learn the two types of differential equation, which is the ODE and PDE. So let's move forward. First is this as the example of differential equation. Here x is an independent variable and y is the dependent variable. For example, dy over dx equals 5x. A differential equation contains derivatives which are either partial derivatives or ordinary derivatives. The derivative represents a rate of change, and the differential equation describes a relationship between the quantity that continuously varying with respect to the change in another quantity. There are a lot of differential equation formulas to find the solution of derivatives. And this is the second one. Verify the function the y equals e minus 3x plus 2x plus 3y equals e minus 3x plus 2x plus 3 is a solution to the differential equation of y prime plus 3y equals 6x plus 11y prime plus 3y equals 6x plus 11. And this is the solution. To verify the solution, we first calculate the y prime using the chain rule for derivatives. This gives y prime equals negative 3e minus 3x plus 2y prime equals negative 3e minus 3x plus 2. Next, we substitute the y to y and y prime to y prime into the left hand side of differential equation. For this one, quantity of negative 3e minus 2x plus 2 plus 3 quantity of e minus 2x plus 2x plus 3 times quantity of negative 3e minus 2x plus 2 plus 3 of quantity of e minus 2x plus 2x plus 3. The resulting of expression can be simplified by first distributing to eliminate the parentheses giving. For this one, negative 3e minus 2x plus 2 plus 3e minus 2x plus 6x plus 9 times negative 3e minus 2x plus 2 plus 3e minus 2x plus 6x plus 9. Combining like terms leads to the expressions. This one, 6x plus 116x plus 11, which is equal to the right-hand side of the differential equation. This result verifies that y equals e minus 3x plus 2y plus 3y equals e minus 3x plus 2x plus 3 is a solution of differential equation. For this one is the third example. Find the particular solution to the differential equation of y prime equal to 2xy prime equals 2x, passing through the point of quantity 2y times quantity 7. The solution is any function of the form y equals x2 plus cy equals x2 plus c is a solution to this differential equation. To determine the value of cc, we substitute the value of x equals 2x equals 2 and y equals 7y equals 7 into this equation and solve for cc. Therefore, y equals x2 plus c7 equals 22 plus c equals 4 plus cc equals to 3 times y equals x2 plus c7 equals 22 plus c equals 4 plus cc equals to 3. Therefore, the particular solution passing through the point of quantity of 7 times quantity of 7 is y equals x2 plus 3y equals x2 plus 3. For this part, this is what is the use of differential equation, by the way. Okay, the main purpose of differential equation is to compute the function of differential equation is to compute the function is over entire domain. It is used to describe the exponential growth or decay over time. It has the ability to predict the world around us. It is widely used in various fields as physics, chemistry, biology, economics, and so on. For this part, this is the type of differential equation. I can also explain you what is the type of the first type of differential equation. What is ordinary differential equation? Okay, first is this is the ODE. An ordinary differential equation, also abbreviated as ODE in mathematics, is an equation which consists of one or more function of one independent variable, along with their derivatives. A differential equation is an equation that contains a function with one or more derivatives, but in the case of ODE, the word ordinary is used for the derivative of the functions for a single independent variable. And this is the example to further understand about ODE. The question is find the solution to the ordinary differential equation. Y prime equal 2x plus 1. This is the solution. The given is y prime equals 2x plus 1. Now integrate on the both sides. Integral y prime dx equals integral of quantity of 2x plus 1 dx. Y equals 2x squared over 2 plus x plus c. Y equals x squared plus x plus c, where c is an arbitrary constant. That's the example of ODE. And the second one is what is partial differential equation definition. Okay, let's move forward for the slide. Okay, a partial differential equation, commonly denoted as PDE, is a differential equation containing a partial derivatives of independent variable, one or more with more than one independent variable. A PDE for a function is u quantity x sub 1 to x sub n is an equation of the form this one. The PDE is said to be linear if f is a linear function of u and its derivatives. The simple PDE is given by this one. Partial differential u over partial derivative x quantity of x, y equals to 0. The above relationship implies that the function of u quantity of x, y is independent of x, which is reduced from a partial differential equation formula stated above for this one, or this is below, rather. The order of PDE is the order of the highest derivative terms of the equation. And this is the example to further understand what is PDA. This is a question. Shows that if A is a constant, then U quantity of xt equals sine quantity at cos quantity x is a solution of partial derivative 2 u partial derivative of t2 equals a2 partial derivative 2 u of partial derivative x2. And this is the solution. Since a is a constant, the partials with respect to t are the partial derivative of u and partial derivative of t equals a cos quantity of a2 cos x. Partial derivative 2u or partial derivative t2 equals negative a2 sine quantity of at cos x. Moreover, u sub x equals negative sine quantity of at sine x and u x equals to negative sine quantity of at cos quantity of x, so that a2 of partial derivative 2u of partial derivative of x2 equals to negative a2 sine quantity of at cos x. Therefore, u quantity of xt equals to sine quantity of at cos quantity of x is a solution to partial derivative of 2u and partial derivative 2t equals to a to partial derivative 2u and partial derivative of x2. Hence, prove and for this part, we'll learn also the order of differential equation. What is differential equation? The order differential equation. The order of differential equation is an order of the highest order derivative represent an equation. Here some example for different order of the differential equation are given below. This is the first one, dy over dx equals 3x plus 2. The order of the equation is 1, and the second one is quantity of d squared y equals dx squared plus 2 quantity of dy over dx plus y equals to 0. The order is 2. And this is the third one. Quantity of dy over dx plus y equals kt. The order is 1. That's the order of differential equation. Next is the first order differential equation. You can see in the first example, it is a first order differential equation, right? Which has degree equal to 1. All the linear equations in the form of derivatives are in the first order. It is only the first derivative such as dy over dx, where x and y are the two variables and is represented as dy over dx equals f quantity of x and y equals y prime. The second order differential equation is the equation which includes second order derivative is the second order differential equation. It is represented as d over dx quantity of dy over dx equals to d squared y over dx squared equals f 2 primes x equals y 2 primes. And this is another one. What is the degree of differential equation? We talk about for this video also. The degree of differential equation is the power of the highest order derivative, where the original equation is represented in the form of a polynomial equation and derivatives such as y prime, y second prime, and y third prime, and so on. Suppose the quantity of d squared y over dx squared plus 2 of quantity dy over dx plus y equals to 0. It's a differential equation, so the degree of this equation here is 1. See some more example here. dy over dx plus 1 equals to 0. Degree is 1. And this is the second one. Quantity of y third prime cube plus 3y second prime plus 6y prime equals to 12 equals to 0. Or the degree is 3. I think that this is the end of this tutorial. I hope that you learned a lot from differential equation and what is differential equation is. Okay, for this video, I hope that you learned a lot from this one. And thank you so much, and don't forget this one. Mathematics is not about numbers or equations, or computation or the algorithm. Is about understanding by William Paul Johnston. Okay, thank you so much for this one. I hope you watch this one and learn about introduction of differential equation. Thank you so much, and I hope to see you in the next vlog. Goodbye, guys.